All right. So yeah, this session is now being recorded. So right. So I guess let's get started. So this is I'm gonna So this is Gopher, and he is like the symbol, I guess, of Golang. And today, me and Gopher will take you guys on a journey, I guess, and teach you guys about Golang. And I don't really expect too much participation, in the sense that almost all of this you can just look at it and be okay with it, but some of it might have participation. Yeah. So so firstly, I guess some logistics. The check-in code for today is G0 exclamation mark. So head on over to ACM membership portal and use it. And slides are available at this URL. And we'll be using the Go playground to run all code. So you can go there and run examples along with me if you wanna experiment yourself or something like that. But and the slides are online. So if it feels too easy, because some of you guys have taken CSE 30 and everything, maybe some of the concepts are too obvious, I guess. So you can actually just skip ahead and see what we're doing later. And about installing Go, I will not discuss how to install Go, because it's actually kind of painful to install Go. And I guess in some way this presentation is a pitch for Go, and I hope I can convince you guys to install Go once you're done with this presentation. So let's get started, I guess. So obviously one of the first questions is why would you pick Go out of all the different Rust and all the cool new languages? So I guess one of the main reasons would be that Go is really simple, in the sense that there's only 25 different keywords in the entire language. There's no there's no C++ and everything. They have so much different operators, different defaults and weird things that are just not fun to use. Go just gets rid of all of them by just having really few keywords, having really minimal language structure and letting you implement everything you want to. It's obviously garbage collected, statically typed, all those things. But one of the main interesting things about Go is that it's concurrent. So I'll discuss concurrency later, but in some ways it means that it's parallel, but it's really good at being parallel, if that makes sense. I don't know. And then other than that, errors are first-class citizens in Go, which basically means that errors are not, you don't have to use try catches and things like that are so ugly to, deal with errors. Errors are return values, if that makes sense. So it treats errors in the real world, there's a lot of errors, and you can't have millions of try catches everywhere. So it just treats errors like first-class citizens, and it's object-oriented, but not in the standard way, I guess. I won't really discuss that, but I guess it's just a thing to know. And it's pretty much like C in many ways, but there's no pointer arithmetic and all that stuff that people usually hate about C. So I guess that's an advantage. Yeah. So let's move on. Yeah. So first thing is just a hello world. So in Go, you start everything in a package, and that package main would be one of the main program, in C or C++. And so you next our line is import FMT. FMT is sort of C has standard IO, C++ has IO stream, Java has system.out and system.in, all those things. So it's basically it's sort of general utility functions, printing, sprintf, things like that. And so in our main, we just have a func is the keyword for functions. And in main, you just have a single line which is fmt.println and your string. So there's no semicolons, as you may have noticed. And yeah, this is how you do hello world in Go. So next. So I'm going to talk a little bit about like what kinds of constants and variable types Go supports. So obviously there's all your standard Boolean, strings, integers, floating points, all those things. There's also complex numbers for the math CS majors here. If you guys ever need to do complex geometry or math or something, it's really nice to work in Go. And type is specified on declaration in Go, and everything is everything has default 0 values, and it is initialized with default 0 values if you don't set one. So yeah, it's kind of like I guess Java in that way, but yeah. So let's move on to the next slide. So yeah, let's look at some actual code, I guess, for this. So this is sort of the general pattern for declaring a variable. Like you'll have const or var followed by a list of variables, and at the end there's a type. And yeah, so you can declare at like package level, function level, and later we'll talk a little bit about methods, and there you can also implement in structs and stuff. But yeah, for now, just worry about these two scopes, I guess. And and I guess this is a declaration where we also have to specify the values, but it's kind of ugly, right? In the sense that you have 2 lines, each of the lines just assigns a variable value. So actually you don't have to do that. Go lets you compress everything into a single line and just write a list. And in this list, like things are assigned, like 5 is assigned to P, 9 is assigned to Q, and it's like sequential like that. So you can do that. And in fact, actually, do I really have to tell Go that it's an int? Like, shouldn't it just automatically know that 5 and 9 are ints? So P and Q are also ints. Actually, Go lets you do that. So you don't actually have to write that. You can just do this. And in fact, there's an even shorter hand. And you can just omit var as well and just write PQ and this symbol where you have colon equals sign and the list of variables. So yeah, you can do that. And I mean, this is pretty cool, I guess. And you can also have like multiple different types, like variables of different types in the same line. So Q will now be a float because it's 9.5, and P will be an int because it's 5. Yeah, so again, println is just printing out the variables to stand it out, just so it's, I mean, if you want to run this code, you can actually run it and check that it works. So now let's look at functions. So this is kind of what a function looks like in Go. You obviously, as you saw with main, you have a func keyword at the beginning, then you have the function name, and then you have, like in the brackets, a bunch of variables, which are the parameters or the arguments for the function. And after that, you have the return type, or all the return values and their types. So for example, in this function, math, I guess, you only have an int return, like x plus y is an int and there's only one of them, so that's it. And if you do next, yeah, so you have, these are function parameters in the brackets. And actually, as with variable declarations, you don't have to repeat this int. You can just use lists, and you can compress everything into one list followed by the type. Similarly, you have int, which denotes the return type of x plus y, and you can actually have multiple return values in Go. So what that means is that you can have a function return like a tuple of values. So here you can return x plus y and x minus y, and in that case, your function signature also specifies like all the different variables in a list that can be returned. So yeah, and yeah, this is again the general structure. You have a func or the keyword func, the name of the function, the parameters, and return values. So yeah, that was that. Do you guys have any questions up until now? I guess not. So yeah, let's just move on then. So if and switch. So just the general conditional statements in Go. Like every language has if and switch, I guess. So yeah, if is basically the same as C, and switch is somewhat different, but it's different in a good way. Like there's no automatic fall through or weird, like those trick questions that I guess in UCSG and CSE 11 and everything. They used to ask about switch, like how will a different condition execute, and then if there's no break or something, and it'll fall through. That was like really annoying for me at least. So Go gets rid of all that. So let's look at an actual example of if. So here we have this program that prints what operating system is like this code block running on. So you have an if condition, an else if condition, and like an else condition. Notice that there's no parentheses around the actual conditions. It's just a straight line. So that's kind of clean. So you have this variable OS assigned here, and then you use it in your if condition, right? But I mean, you don't need to use it afterwards. Like it's only used for executing the if condition. So actually, Go allows you to like write an if statement with a shorter statement in the beginning that is executed before a condition is checked. So, for example, from earlier we had this OS that was being assigned in one line, and it was just being used in the next line, and that's it. So you can compress it into like one line where OS is assigned, and then OS is compared to everything. But notice that you can't use OS outside the scope of the if conditions. You can use it here, like in the else if condition, but you can't use it outside. So, I mean, that's a very common pattern in Go, that you have like a short like statement just after an if, and then that variable or some assignment is used to compute like an if condition. So yeah, that's how Go uses it. So I hope everything's clear until now. So now let's look at switch. So switch is you just start with a similar syntax where you have like a switch, an assignment, and like something executing a variable or something that switch will execute on. So for example, here OS is compared to Darwin or Linux or whatever. So this is exactly equivalent to the if condition we wrote earlier. So yeah, you can also do this like we did before. Like you don't have to have everything in the same line. You can instead do this, where you assign OS first, and then you don't even need to specify a variable for the switch to act on. Like your cases can be actual conditions, like an if-else. And yeah, I mean, this is exactly the same thing if OS is Darwin or Linux or whatever. So yeah, now let's look at defer. Defer is sort of like, defer just executes a function after like the surrounding function is like done with everything. So for example, here if you have this defer statement with world, but nothing attached to a hello, hello will execute first in our terminal. The right side is going to be the terminal in most of these examples. So yeah, I think I have it labeled, but yeah. So it prints hello world, as you would expect. The defer executes after hello when main is finished. So if you have something more complicated, like if you iterate from 0 to 10, and then in each you defer a print execution. Then you print done. So done gets printed first, and then after that you print 987654321. So the way it works is defer has a stack, and it prints everything, or it executes everything in a like last in first out order. So whatever was executed, whatever defer was at the end gets executed first. So defer fmt.println 9 was the last statement that was executed attached to defer. So that's the one that's executed here first. So yeah. Now let's look at actually looping, how you write loops, because you know how to write conditions, I guess, in Go, and you know how to write basic like arithmetic and functions and stuff like that. So now let's look at actually doing something useful with like programming, I guess, and actually figuring out how to loop. This, I guess, a very basic thing. So a for loop has 3 parts. The first part is the init statement, where it just initializes variables and all those things. And the second part is a condition, which is evaluated after each and every like iteration, and if it's still true, it'll keep running. And the third part is like the post statement. That is what happens after the body of the for is executed. Again, note that there are no parentheses around the for 3 statements, which is sort of different compared to C. And yeah, I mean, this is an entire program. So this program computes the sum of all integers from 1 to 10. And yeah, I mean, you just use sum plus is equal to I. Notice that we use the shorthand operator that we talked about like a lot earlier. And yeah, that's how you, I guess, compute sums of things. So now let's look at a slightly different loop. So here you have this loop where you're actually working with sum. So while sum is sort of less than 1000, you add to sum, and then you add sum to sum. I don't know, it's some weird computation. It doesn't really matter what the computation is. But my point is that sometimes you have code where you will notice that your like init and your post is kind of redundant. So in Go, you don't actually have to specify your init and your post statements. You can just get rid of them. So like this, the post statement and the init statement is just optional. So here you just have a condition that's executed each time like the body of the for loop is executed, and while it's true, it'll keep running. And I mean, these like semicolons are also kind of useless. So let's get rid of those two. Right. So now you just notice that like the keyword while in C, C++, or Java is really just for in Go, which is kind of neat. So yeah. And let's say you now realize that I want this to run forever. I don't like. I just like. I don't know. You're some madman who just really likes to run for loops. So you can just like drop any condition. So if you just write for and just have a body, that's just looping forever. It's like for true. So at this point, do you guys have any questions? Right. Yeah, Storm's right. It's used a lot in file closing patterns, defer. So Storm was talking about defer being used in, yeah, right. Defer being used in file closing and stuff like that. So yeah, if you do file I/O, it's really convenient to have defer, so you can just easily get done with files without having to keep track of all the files you've opened and closed and all those things. So yeah. Does anyone else have any questions? Click the webpage. Oh yeah, Emily, the second slide has Go, or like it's G0 exclamation mark. Yeah. The slide is in the shared notes. All right. So yeah, let's continue, I guess. So yeah, we just talked about looping. So yeah, I mean, I hope like for loops make sense. The only really cool part about Go is that like for loops are really also while loops, which I mean is kind of amusing and kind of surprising that other languages didn't actually, you know, um, like why did even any languages create while and do while when you could just have the same keyword that like completely makes sense. Like if you do maths or something, it makes so much sense that you have for all or for like if you write summation notation or something. This kind of notation is really common in math. So I'm not sure why it took so long to actually make this a standardized language notation in programming. But yeah, let's move on. So at this point, I mean, I've told you a lot of things about looping or variable assignments and things like that. But really, I mean, all of us come to workshops to improve our resumes, right? So I mean, I'm gonna help you improve your resume and actually solve Go questions in an interview. So let's just start with FizzBuzz because that's, I guess, one of the most popular programming interview questions according to certain websites. So yeah, a number is said to be fizz if it's divisible by 3. So like 3, 6, 9, all those numbers will be fizz. It's called buzz if it's divisible by 5. And it's called FizzBuzz if it's divisible by both 3 and 5. So like 15 or something, that's FizzBuzz. So write a program that calculates the number of numbers that are fizz, buzz, or FizzBuzz, or none of the above in like 0 and 99, between 0 and 99. And once you're done, put the output of your code in the chat. So for this, you can use the Go playground. I think you can actually see the URL is just played.golang.org if you don't want to open the slides. But yes. So if you want a boilerplate, one slide. There is a page on this website. Sorry. I clicked the Go link and apparently Netlify doesn't understand page numbers. Yeah, so we're back. Yeah. So yeah, now if you look at this exercise, just go to the Go playground and actually start typing. If you need like some boilerplate, like all the things we've been using in the previous examples, start with package main, import fmt, and like have a func main, and start writing in those functions. Yeah. So I guess I'll wait for around 5 minutes. Right, Ronak, sure. So for loop is written like this. Yeah. So you start with like wait. Interesting. Oh wow. Right. You start with init statement, a condition, and a post statement. Yes, that's basically while. That's exactly what I was talking about. Like, it's interesting how while even exists in other language. Like, it should just be called for, in my opinion. These while is for the idea. Um, one. Interesting. So it is lacking for everyone. Alright, anyway, so FizzBuzz, coding time. Go to text. Yes, Storm is right. If there's a actually, if there is a semicolon and there's no like the init and the post statement are blank, that is also like technically a while loop. Yeah, I guess in the meantime, I guess I can play some music. I don't know if you guys can hear it, but you know, some coding music for you guys who are doing the FizzBuzz. Uh, what is a good coding style of music? I don't know. I just like to listen to piano. I guess you can just listen to that. I mean, you guys don't really have a choice if you don't like it. So, uh, can you guys hear it? I'm not sure if you guys can hear it. Wait, am I disconnected? You guys hear me, right? Okay, that's good. But can you hear the music? Oh, interesting. Huh. Sad. Mm, Actually, if I play the music on, hmm, I think I can figure this out. But anyways, you guys in the meantime work on FizzBuzz. Again, remember how we wrote a for loop, and remember how we had an if condition. There's no parentheses if you guys are coming from C or C++. It's basically until now, I guess, just C or C++ without parentheses. So if you guys are like close to getting done, like again, put the output of your code that is like the number of numbers that are FizzBuzz, or neither. So there should be 4 numbers in the chat. I think you guys should hear music now. Well, we have someone in the chat named Mike, so I mean, they can just you know provide us an extra mic, I guess, but and play the music. But never mind, bad chat. Okay, I'll make it a little bit louder. So I do have a timer here. So I think I'll wait like 5 minutes or so, or like just if you guys are still working on it, like just let me know. So I can wait. For those of you who are not actually writing code, I'll make a poll just so I get some sense of CSV. Yeah, I'll just make a poll so you guys can also do something. This also helps me, I guess, understand what kind of audience I have, so I can edit my presentation. But it's too late to do that now. So yeah. Well, we have a lot of CSE 100 plus people now. I guess everyone from board is CSE 100 plus. Oh, Thomas, I used this tool called MDX Deck, and I think I have a link in the last page of the slides as well to the software. It's kind of painful to use, honestly, because it's really buggy, but yeah, I mean, you can try to use it if you want to make slides, I guess. Right, so we have a lot of CSE 12 people, and some people who are at CSE 30, and a lot of people who are at CSE 100 plus. So yeah, I mean, again, if you are, feeling like I'm too slow or something, you can always skip ahead. The slides are at acmurl.com/golang. Or, I mean, just let me know if I'm too fast, otherwise. So we are actually 5 minutes in. Is anyone still working on it, or should I just show you guys how to, like, we can write it together, basically, with these slides. Yeah, the slides are a little bit buggy, but yeah, it's fine. Yeah, that's the name Storm posted. There's another tool, or not tool, I guess, a library called Code Surfer, which you can use to do the code surfing thing. So yeah, I guess I'll just proceed. No one posted answers, so right. So we had this boilerplate, I guess, that was just like our package main, import fmt, and a func main. So in our func main, let's actually have some variables first. We have a fizz, buzz, or neither. And again, this is, like we discussed, you start with the var keyword and you end with the type of the variable. Let's also print the variables. So fizz, buzz, neither. So if you just run this program, quick question, what do you think the answer would be for, what do you think it will print? Just put your answer in chat. Yeah, Christopher is right. So it'll just be zeros, because in Go, all variables are by default given some default value. For ints, it's 0. So yeah. Anyway, back to our old fizzbuzz. Let's actually loop over the numbers that we are going to deal with. So from 0 to 99 inclusive. So we start with the initial statement I is 0. Again, we use a shorthand notation, which I mentioned. It means that declare a variable named I and assign 0 to it. Then we have this condition expression, which executes after each body, like every other language, and I++ is just like every other language. And inside this loop, I'm not really sure what I want to do. So let's just say that I'm calling some function called fizzbuzzer that executes whatever needs to be executed. So yeah, let's write fizzbuzzer I, and into fizzbuzzer let's pass a variable called x, which is an int, and you need the func keyword to start your, function. Inside it, let's write the function body. So if a variable is divisible by both 3 and 5, add 1 to fizzbuzz, and so on. If it's divisible by 3, fizz. If it's 5, then buzz. Otherwise, neither. So yeah, that's basically it. That's all you need to write. So you have these variables that are at global scope that are used by fizzbuzzer and also used in main to print actual values. And so, did anyone actually write the code? Oh yeah, Storm actually wrote the code in a Golang playground. So yeah, Storm, does your answer actually print the same value, 27, 13, 7, 53? And I'm actually trying to run his. Oh, you wrote the actual fizzbuzz. So our fizzbuzz was a little bit different, just so it's easier to put it in chat. So yeah, yeah, it's fine. It's basically the same thing, but it was just easier to compute the actual values of the number of numbers and put it in chat. But yeah, the value should be 27, 13, 7, 53. If you guys are still working on it, just take your time. And yeah, I'll actually put these in chat just so you guys can look it up. All right, so let's move on then. So we talked about some of the different types, int and all those things. But actually, Go offers some really cool types like slices and maps. But before we get to that, let's talk about pointers and structs. Oh, Storm, it looks like oh yeah, that works. So yeah. So again, I was talking about pointers, structs, slices, and maps next. So let's start with pointers. So Go supports pointers, and it's basically like C. So you can point to a variable using ampersand, and same way as a normal variable, you can use the shorthand notation to assign a value to a pointer and have a declaration, I guess, at the same time. And for printing, you use the star operator, just like C or C++. And you can also do some modifications. So pointers are not immutable or mutable or other way around, whatever. You can edit the values inside them. So you can set a pointer to be pointing to J, and then you can have the value inside the pointer be edited. So you can do that. And there is actually no pointer arithmetic, which is one of the best, in my opinion, things about Go. So you can't have really complex or weird, pointer access, which also reduces a lot of the seg fault and all those errors that are usually associated with pointers and pointer arithmetic. So that's actually really nice. So yeah, if you actually type it out, like P++, it'll tell you that invalid operation, P++, and non-numeric types pointer to an int. That's the error that you'll get. So now let's quickly look at structs. This is how you declare a struct. You use type, you type the name, I guess, of the struct, and then you use the keyword struct, and inside it, you just list out all the variables. Like you can list x, y, and int, and you can have more lines if you have more variables. But unlike C or C++, you can't have class, not methods. I guess the right word would be class functions. There is a way to make methods in Go, which I'll briefly talk about later. Yeah, but this is how you essentially declare a struct. And this is how you use structs. For example, you can just pass a list into the struct, and it will auto-assign x to be 1, y to be 2, and v1 would be a type vertex. You can also use labels. So x would be 1, and since you didn't provide a value for y, as we have seen previously, y would just be 0 implicitly. You can also just leave it empty, and everything would take the default values. Or you can use pointers to access a vertex. So for example, p is a pointer to a vertex, and you can use things related to that. And if you want to use access members of a variable, you use the dot operator, and just like C or C++. Right, so does anyone have any questions up until now? If you want pointer arithmetic, you can use unsafe.pointer. Right, but I don't think I've ever seen good code do that. But yeah, I mean, if you want to play with fire, go ahead. Go Struct natively support JSON marshalling and unmarshalling. Right. I mean, that's not really that interesting for me, at least, because it's too technical detail, and even otherwise, you can easily implement those things. But yeah, I mean, that is a cool feature, I guess. Right. So, anyways, moving along. So, right, this was our struct program. We declared a struct with x and y parameters, and then we had a bunch of variables that assigned values to the struct in different ways. And we also had some printing going on here with the dot operator. So yeah, all those things are very similar to C or C++. So let's move on. So arrays. So they're pretty standard, I guess. To write arrays, you can use the brackets. In between the brackets, you have the number or the size of the array, and follow it up by the type. And you can also use this notation to initialize and set the internal values of the array at the same time. So arrays in Go are not resizable. It seems like a really limiting feature, but it actually isn't. I'll talk about how Go provides support for working with good arrays, or working with arrays that need to be resized or things like that. So yeah, those ways are called slices, and slices are sort of like a dynamic view into an array. So it's like a window into, or like a smaller window into an array. So how do you declare a slice, I guess? So you start with the var keyword, like always. You call the variable name, I guess, s for slice. You write the brackets followed by the type, just like you would write in an array, but you leave the number out. So this is essentially tell Go that this is a slice, and to assign it, you use you can use a lot of different things, but one of the ways to assign a value to a slice would be to give it a window into an array. So here I give it the window 1 to 4, so 3, 5, 7, 11 into primes. So just like, I guess, Python, you can omit the bounds, so you don't need a higher bound, and you also don't need a lower bound if you don't want it. And yeah, so resizing slices. So the main problem with arrays is that you can't resize them. In Go, you can resize slices though. So for example, if I start with this slice, which is the primes array from the previous slide, and if I try to print it here, right, if I try to give it 0 size and then print it, it'll be an empty slide, empty array, or not array, a slice, but it'll just be empty brackets in your printing. And now let's say you want to resize it, right? So even though I set it to be empty in the previous one, if I now resize it to 4, Go automatically knows that there is sort of an underlying array that is this array, and it automatically assigns the values from that array into the extended slice. So here, earlier we had an empty slice. After this, you had an empty slice, and when I extended it to be like a larger size, it automatically resized the size to contain 2, 3, 5, 7, which were the first 4 elements. So yeah, the question comes up, what happens when you resize an array to be really large? So for example, if instead of 4, I wrote like 100 or 20. So you guys have 4 options. What do you guys think would happen? Let me start a poll. A, B, C, D. Right. Oh wow, there is a lot of split. Do you guys see the poll? Does everyone see the poll? Right, okay. So people are responding. Okay. Alright, so a lot of people think A will happen. There's a couple people who think B and C would happen. So, I mean, I guess this is a bit of a trick question, but actually, the answer is C. So, it gives you a runtime error, and it gives you a runtime error, and it just panics and prints like an error message that slice bounds out of range 20 or whatever with capacity 6. So again, think about the idea that every slice has an underlying array, and that array has certain capacity, like the array size bounds the size of the slice, and it's called the capacity in Go. So there's actually a function called cap. So you can call cap of a slice, and it'll tell you what the maximum capacity of a slice is. Yeah, pretty interesting. Like, you would think that it would make sense to do like a fill with zeros for the rest of it, but it also kind of makes sense that a slice is a window into an array. So it should not, like a window should not be larger than a wall the window is on. So I guess that's kind of the analogy. So yeah, now let's look at maps. Maps are pretty much like every other language, like I guess C++, JavaScript, or all those languages. So here we have a map that is a key value association in the way that there's a key that can be a certain type, which here is a string, and there's a value assigned to each key, which can be any type. And remember our old vertex struct? We still have that, and we can use that as a value in our map. So obviously, how do you actually initialize a map? So once you declare a map, it's just a declared map. It's nil in value. It doesn't actually, you can't actually store elements into it. So before you store elements into it, you have to call the make function, and you have to tell it to make a map of strings and vertex. And after that, you can obviously use like strings with certain values. Right. So now let's get back to our old trusty FizzBuzz, because I mean, after all, I'm gonna help you guys pass any interview of Go or anything like that. So let's just start with FizzBuzz back again. So yeah, we have learned a lot since our previous iteration of FizzBuzz. So we learned how maps and slices work. So let's actually use a map somewhere. So let's see, what can we replace here? So here we have like a bunch of variables, right? There's like 4 of them. I mean, that's a lot of variables. What if, I have to add like another fizz, buzz, and a third one like bez or something, I don't know. So that would be 2 to the 3, like 8 variables instead of 4. And that's exponential growth. So let's use a map instead. So replace it with a map, and here we have a map of strings which maps to integers, because we have strings like the fizz, buzz, and meter, and int would be the value we store. And let's also initialize the map in main. And again, we use the make function along with the same way of the type. And let's actually replace our logic to use the map. So here we'll call m fizzbuzz, and we like add 1 to it. So one valid question would be, what happens if like fizzbuzz is empty? Like there's no entry of fizzbuzz. So just like normal variables, there'll be a default value of 0. So everything's fine. So now, I mean, we're printing the map here, but it's not that pretty. So there's actually a prettier way to print maps in Go. You can use the function range, and range returns 2 values: the index and, or not the index in case of map, the key and the value, and all pairs of these things. And you can just call println in your for loop to print them. And if, let's say, you don't want to like write the key because you know the key, like there's only 4 different values here, so you can use the underscore operator to ignore a return value. And actually, you can use an underscore anywhere. So let's say you have a function that returns like 5 different values, but you really only care about 3 of them. So you can use an underscore to ignore the other 2 values. So yeah, does that make sense? Does anyone have any questions up until now? Oh, I see Mick did the right fizzbuzz. Yeah, that seems correct. Pretty cool. So yeah, let's get back into our code. So at this point, we know enough about Go to talk about concurrency. So I think concurrency is one of the best ideas in Go, in the sense that it's one of the cleanest implementations of parallelism, or any of those cool execution things that we see. So obviously the question comes, what is concurrency? So concurrency itself is the idea of a composition of different computations. So it's like the I guess the orchestra master for an orchestra of operations. So you can have different kinds of operations, and it doesn't even have to be computation. It can just be passing variables or things like that. And concurrency is the way of representing those structures in a programming language or in a computer science environment, I guess. So yeah, that's concurrency. One of the common misconceptions, I guess, is that concurrency is parallelism, but they're not the same things. Concurrency is a model for implementing or managing parallelism, but parallelism itself is the idea of executing a lot of things together. Concurrency is just organizing a lot of things to execute. So I mean, you can actually read this entire whole argument, or not argument, I guess, the philosophy of concurrency. It's really long. It's 50 minutes, but so I won't get into it. But it's pretty interesting how we think about different things, and how they get implemented, and how they change how we think about the concepts themselves. So for a concrete example, I guess you can think of a computer that only has one processor. Your program can be concurrent on a computer with only one processor, but it cannot be parallel, because parallel needs you to run multiple things together. But concurrent is just representing it in a way that your things can be executed intermittently. So you can have some execution of thread A, I guess, and thread B can be executed on the same exact processor at the same time, or not on the same time, but intermittently, if that makes sense. So yeah, let's actually look at some of the structures Go makes to help us implement concurrency. or not help us, I guess, help itself implement concurrency. So here we start with like a rather simple function. Let's just call it printer, and it just does nothing. It just prints the variable x to standard out. And in our main, let's just call the printer a bunch of times. So it just prints all the values. So actually, we can write just one keyword change to implement parallel printing, I guess. So if you write go printer I, it just parallelizes the printer function in the sense that it just tells it to, go run. I don't care about the return values. I don't care about how you execute. Just, go run on your own. So that's how you write, or that's how you tell a Go to run a function in concurrent way. And yeah, if you write that, however, you'll notice that nothing will get printed. Like if you actually take this code and put it in Playground, you'll see that nothing gets printed. And that's because actually main exits right after this for loop runs. And the way Go works, if main exits, the entire program exits. So like those threads that you spawn that were supposed to print X don't actually do anything. So yeah, how do we prevent that? Like, what can we do to not have to, deal with that? Well, a simple way would be to just make the program sleep for a little bit. And if you, make it sleep for a little bit, what that just does, it just pauses execution, I guess, for a while for main. And in the meantime, the concurrent threads from printer will finish executing. So if you run this, you'll see the output is something like this. And it's running in parallel because the variable values are out of order, 0 got printed after 1 and 4 after 2, and yeah, whatever. But you get the idea. So now this is kind of hacky, right? I mean, sure it works, but we don't really know how long it might take to execute printer, right, in all the cases. So Go actually provides a really neat structure called channels to support communication between Go routines. So when you call a function with a Go keyword before it, it spawns a Go routine. It's like the word coroutine, but with a G. That's just what Go calls it. And I guess it's unique enough in Go that they think that calling it separately Go routine and not core routine makes sense. So yeah, so from now on, if you see the word Go routine, it means that it's just a function that's being run and it's been told to run concurrently. So let's get back to channels. So Go provides channels to help communicate between different Go routines and different functions that might be running in concurrent or not. So channels are first-class citizens, just like errors or just like actual variables. Channels are built into the language and very deeply ingrained into the language. So if you use JavaScript or some other languages that are parallel, not concurrent, you must have noticed that you use a lot of mutexes, locks, and weird things like that. Basically, the difference between those languages and Go is that they have a common pool of memory and they use processes to edit that memory. In Go, the approach is that you don't communicate by sharing memory, you share memory by communicating. So your channels are sort of your memory pool, which are passed around all your functions that are concurrent or parallel, if that makes sense. So yeah, now let's actually look at what channels, how channels work. So to initialize or to declare and initialize the channel, we use the same old shorthand notation, and we call make, and we tell it to make a chan of int. So this means that the variable type inside the channel will be an int. So you can only put integers into this channel, ch. So next, let's look at how we send on a channel. So we have this like arrow operator, I guess. This arrow that puts x into ch. So the way to look at it is that the arrow points towards ch, so it's a send into a channel. And then if you want to read the output, this arrow points into a variable. So from ch, you read the value and put it into y, for example. And yeah, again, the arrow indicates the direction of data flow. So if it's pointing into ch, you're reading, you're putting data into it, or vice versa. And again, the whole point of channels seems very easy to understand, but it's extremely powerful in the way that you can create different patterns and things like that to communicate between different Go routines. So did channels make sense? If you guys have any questions, just put them in chat. I'll drink some water in the meantime. So I guess no questions. So let's move on. So now let's look at some interesting patterns. So I mean, patterns is like a broad term. I just wanted to talk about what different concurrent programs in Go look like. So for example, we have this generator pattern, I guess, which if you look closely has a function called generator. Wait, is this supposed to zoom in? Oh, I guess not. There we go. Oh wow, it's not fun. Huh. I think it has something to do with the amount of people that are browsing at the same time. Because it seemed perfectly fine earlier today. Wow, this will take a long time. Right. Remember when we first wrote FizzBuzz? It was so different than the map we use now. So much more powerful, right? Yeah, this one, this FizzBuzz. It now uses a map and it prints using a range. So it's really superior. So yeah, let's get back to Go routines. Sorry that took an interesting turn. This is my first time using the slides and they're interesting, to say the least. So yeah, again, let's look at the generator that we wrote. So we have this function called generator, and inside it, we make a channel. And look at this line, most importantly. What's interesting about it is it's declaring a function closure, which basically means that it's declaring a sub function, which is a variable, I guess. And at the same time, you just call Go on it. So this is how, if you just have a piece of code that you just want to parallelize, you don't want to make a different function or anything like that, you can just declare it as a func right there. So yeah, this is how you declare a closure function. And this just means that we're calling it with nothing. This declares a closure function and this calls it. And putting Go before it is just having a separate function that executes this part. So let's look at what happens inside this parallelized function. So we iterate from x, which is a parameter, to x plus 5. And we put each of the values into the channel. And then we sleep for a random amount of time. This just means it sleeps for a random amount of milliseconds, just to make it interesting. And yeah, ultimately it returns the channel. So notice this pattern that what's interesting about having channels be first class types or first class values is that you can have functions that return channel and you can use that in different ways. So this generator is called generator because it generates a channel with certain values concurrently put into the channel. So for example, if I call generator 0, like I do here, let's call it Alice, just so, it's a nice name. And I set it to generator 0. So inside our program, we have this concurrent piece of code that iterates from 0 to 0 plus 5, which is 5, and puts each of the numbers into the channel and sleeps for a little bit. So if you look back at our main code, inside this channel, we receive from the channel, inside this function, we receive from the channel Alice 5 different times. So we iterate 5 times here as well, and we pull the value out of the channel. So every value that is pushed here gets pulled out here, and I guess that's how you write your simple iteration in a concurrent way. But this is not very useful, right? Because it's I'm not achieving anything out of it. I'm still taking the same amount of time. In fact, I think you'll be taking more time because there is some interesting things about how the threads are managed. So I think this actually takes longer than just having a loop that iterates from 0 to 5. But there's some interesting things that we can do with it. So having a generator means that we can sort of use it like a handle on a service. Use APIs or something. Here with this idea that there are services, and you can have certain API keys or things like that are sort of handled into a service. So here, for example, I can call another guy called Bob and have him iterate from 5. So x would be 5 for him, 5 up to 10, and those values will be put into the channel Bob. So let's say I want to count the table 0, 5, 1, 6, 2, 7, so on. I can actually just call them one by one. So when I call Bob here, it is a blocking call. So what that means is that until Bob's channel receives 5, it won't execute the next line. So if you look at the output here, you'll see that it goes, Alice says 0, Bob says 5, Alice says 1, Bob says 6, and so on and so forth. Again, this is essentially just like having only Alice, but now, because there's another handle into the service generator, both of those count in a log step. So only, none of those can exceed each other. But this is not, that cool, I guess. I don't usually want to, have 2 different values be computed in lockstep. So how can we make those 2 handles independent of each other? So the pattern to do that is use a fan-in function. So fan-in functions are essentially, if I can just show you this image. Yeah. So essentially, you have 2 different gophers or 2 different people who are speaking, and you can have a third person who hears both the people messages and just puts it into a new sort of megaphone and tells it to you. So let's get back to our fan-in code. So let's first look at the fan-in function code. So it takes in 2 channels as parameters, and it returns 1 channel as output. So you'll notice that there's an interesting arrow here and here. What do you guys think that means? Just put your answers in chat. All right, I guess that's a rather hard question to answer because we have not talked about it. So yeah, this basically means that the channels are receive only, or sorry, the channels are send only for this function. So again, look at the direction of the arrow. The arrow points into some, compared to Jan, it points somewhere outward. So everything inside it is a call that is outward from channel, or like calls in other direction would not be valid. But that's not very relevant, but this is an interesting note, I guess. So yeah, in this fan-in function, we declare a new channel called C, and we spawn 2 different Go routines, and each of the Go routines does the same thing. It takes a value from input 1, so this takes a value from input 1, and this puts a value into C. So, and this finally just returns C. So these 2 Go routines just keep running in the background, whereas C just gets returned immediately. So both, when we call fan-in generator 0 and generator 5, which were our old Alice and Bob, fan-in combines them into a single both channel. And if you look at the output in that case, you'll notice that there's some interesting mix-up, like 2 and 3 are together here. Earlier, both of these values were in lockstep, so you couldn't ever have 2 and 3 before 7, but here 7 comes after 3. So sort of the idea is that fan-in functions let anyone who is ready to talk just send their message. So fan-in functions are a really common pattern in Go, just because of how many Go routines you usually spawn. Right. So yeah, again, the fan-in function diagram or Gopher diagram looks like this. So yeah, let's again look at fan-in functions, but now I'll tell you an interesting way to write a fan-in function. So here you have 2 different Go routines, right? You don't actually need both of them. You can actually do this with a single Go routine. So the way to do it is that the language provides an interesting select statement by itself. So the select statement is kind of like switch, but for concurrent Go routines. The way a select statement works is that you have some cases, and whichever case can execute, select will pick that and execute it. So it won't. So for example, it'll see if input 1 can give me a variable, and if in that case it'll assign it to S and execute this. If not, and input 2 gives it a variable, then it'll assign that to S and push it into C. So this is just a cleaner way to write fan-in functions with a single Go routine instead of having a Go routine for each and every sub Go routine that you have. It works exactly the same way. Select also provides an interesting, I guess, pattern in Go, where let's say our generator function is for some reason really bad, and it sleeps a lot in the sense that it can sleep for up to 1,000 seconds, right? And I mean, we don't have time to wait 1,000 seconds for our 2 generators, so we can actually have a timeout for our select statement. And the way to write timeout in Go is that Go standard library provides time, which has a channel provided, time.after. So if select statement doesn't execute anything at all for 1 second, this will just automatically execute this part and return. So this is sort of like a failsafe for when you have like APIs or something. Oftentimes you have unreliable connection or unreliable source of truth, and in that case you can have timeouts easily implemented. Right. So now let's look at another concurrency pattern. This pattern is called daisy chain, but I don't really know why it's called that. But yeah, I guess it's an interesting name. So let's actually first look at the Gopher diagram for a daisy chain concurrency model, I guess. So you sort of have this one Gopher who shouts his message or something into a megaphone. Another Gopher hears it. He shouts his message. Another Gopher hears it, and so on, so on, so on. until finally the guy who wanted to hear it actually gets the information. So this is kind of like the game Chinese Whispers. I mean, I guess I'm not sure if it's really popular or you guys played it, but I remember playing the game Chinese Whispers. This is kind of like that in terms of models. So how does it look like in code? So I won't actually go into a lot of detail because I guess some of the details are rather interesting to say the least. But the whole idea is that here we have this gopher implemented as a function, which takes some information from its gopher on the right, adds, I guess, 1 to it, and puts that information into its left channel. So what this is doing is that it's functioning as one of these gophers, hearing a message and doing something with the message and pushing it forward. So in detail, it looks like you need to have at least one message that is sent to the leftmost guy, and then it'll trickle down, ultimately reach the final guy who is like on the right side, or who's at the end of this chain, I guess. If that makes sense. So does anyone have any questions about the concurrency patterns I've discussed until now? Because these are really what make, I guess, Go an interesting language. That you can have these really intricate patterns based on just the two primitives, channels and Go routines. So yeah, that's really cool in my opinion. But yeah, let's move forward since no one has questions. Yeah. Looks like. So yeah, so now let's do our final iteration of the FizzBuzz program we've been writing since the beginning. So this was our last iteration where we had a map, and we used the map to edit values in it, and we used the map to update stuff, and we had this range that we used to print values. So finally, now we have a FizzBuzz that is actually concurrent. So let's break it down and let's see how we write a concurrent FizzBuzz. So let's use a generator style function to fill a channel with the values between 0 and 100. So again, we use a function closure to declare a function and run it as a Go routine at the same time. So in this closure, we just iterate from 0 to 100, and we just push values into the channel. And once we're done, interestingly, we have this call called close. So close is just a way to indicate to receivers when senders are done. So close is also another, I guess, method that Go provides to communicate between Go routines. So if a channel is closed, you know that execution is done, and you can proceed or do something else. So let's look at how we actually use the channel. So here we have the call to FizzBuzzer, and we just give it the channel this time. So let's look at what FizzBuzzer does. So FizzBuzzer takes a channel as input, and it loops infinitely, as you remember, that if you have nothing in front of a for statement, it functions as a for true, so for forever. So inside this, you receive a value from the channel, and you assign 2 variables instead of just 1. So the second variable is the close value we had earlier. So the second variable, if it's true, it means there can be more elements. If it's false, it means the channel is closed. So we immediately check if that channel is closed, and if it is, we just return. Otherwise, we just proceed with our old computation about FizzBuzz and Fizz and all those things. Yeah, again, just handles the close as the second variable. Channels return 2 values. You don't have to, it's optional to assign the second value. So if you choose to assign it, it'll be the Boolean variable whether or not a channel is open or not. So yeah, that's it actually. this is our final Fizzbuzz. And I think that's all I had for today. Yes, and if you're interested in knowing more about Go and all the different things, I recommend looking up a tour of Go by example, and a lot of these patterns were taken directly from Rob Pike's presentation in Google I/O Play Drive. Rob Pike is the creator of Go, and the illustrations across this presentation were made by Maria Letta, and they are open source, and I believe they're under MIT license. So credit to her. And the slides were made using MDX deck and CodeSurfer. You can find all these links in the slides, which are at acmurl.com/Golang. So yeah, that's it. Do you guys have any questions or anything? Yeah, I mean, if you're interested in more, you can just look up these websites. My main intention today was to show you the cool features of, concurrency and show some basics of the language. And I think, I try to do that. You'll probably in fall or something have some kind of advanced Go workshop if you're interested, Storm. Right. So yeah, I'll stop recording and